The Connecticut River flows at a rate of 4 kilometers per hour for the length of a popular scenic route. In order for a cruiser to travel 60 kilometers upriver and then return in a total of 8 hours, how fast must the boat be able to travel in still water? This is a motion problem, so to familiarize ourselves with a motion problem, we can organize our information in a chart, and we need columns for distance, rate, and time. And we have two motion situations, upstream and downstream. Now, first of all, we start with what we know. We know that the distance upstream and the distance downstream are both 60 kilometers, so we can fill in 60 for both of those. The rates, well, we know the rate of the stream, the current, but we don't know the rate of the boat. We'll call that R. Upstream, we need to subtract the current from the rate of the boat. So that would be R minus 4. Downstream, they add, so the rate downstream would be R plus 4. To get the time, we write it in terms of what we know up here, so we don't introduce more variables. We know that distance equals rate times time, so solving for t, time is distance divided by rate. So we can use upstream, the time would be 60 divided by R minus 4. And downstream, it would be 60 divided by R plus 4. Now, in order to translate to an equation, we need to use the last piece of information we're given, and that is that the times, upstream and downstream, add to 8 hours. That's the total trip time. So our equation then would be 60 over R minus 4, the time upstream, plus 60 over R plus 4, that's the time downstream, equals 8. And we can carry out by solving this equation, first multiplying both sides of the equation by the least common multiple of the denominators, R minus 4 times R plus 4. We multiply that by the left side, that's 60 over R minus 4, plus 60 over R plus 4. And we also multiply that by 8, which is the right side of the equation. R minus 4 times R plus 4 times 8. When we simplify, when we multiply this by the first equation, the first expression, the R minus 4 and R minus 4 will cancel, and we'll be left with 60 times R plus 4, plus, we multiply this by the second rational expression. In this case, the R plus 4 over R plus 4 will cancel. So we'll be left with 60 times R minus 4. And on this side of the equation, let's multiply R minus 4 times R plus 4. We get R squared minus 16 times 8. Now let's simplify here. This would give us 60R plus 240 plus 60R minus 240 equals 8R squared minus 128, which is 8 times 16. 240 minus 240 is 0. 60R plus 60R is 120R. So we subtract that from both sides and we get 0 equals 8R squared minus the 120R from the other side of the equation minus 128. If we divide everything, well, we can factor out an 8 and then factor the remaining trinomial, and we get 8 times R minus 16 times R plus 1. So that means R has to be 16, because then R minus 16 would be 0, or R can be negative 1, setting each of those factors equal to 0. Now when we get to the check step, we have to think what our problem was about. It was about the rate of the boat. Negative 1 does not make sense in that situation, so we're left with 16 as a possibility. If we substitute 16 for R, we would find that the times would add to 8 hours. So it checks, and we say the rate of the boat, or the speed of the boat, has to be 16 kilometers per hour.